Dear students, welcome and thank you for tuning into this video. I'm Dr. Loay Al-Zube. This is the third video of the introduction to the measurements of the respiratory system. In the previous two videos, I talked about respiration in general, what it is and what are the components of our respiratory system, and about the control of respiration and components and players that stimulate and suppress respiratory rate. In this video, I would like to talk about and explain lung volumes and capacities. Remember that we are in a medical instrumentation class and we would like to measure quantities that are very important in our respiratory system. These are the volumes and capacities of the gases that are exchanged in our respiratory system. So the first thing I would like to show you is this schematic, which shows the volume of gas or air that is flowing in and out of the lungs, and we can see that we have a lot of rhythmicity in the respiration, and I'm going to be explaining what are those and quantities. We are going to talk about all of these here, and you will learn what they are and how they are actually important in our respiratory system. So the first thing I would like to start with is explaining lung volumes. They are all for a standard 70 kilogram male breathing at rest. So the first thing that we'd like to define is something called tidal volume, and this is roughly 500 milliliters for a standard 70 kilogram male, and that is this quantity here, the tidal volume. And what the definition of this value is the depth of breathing or the volume of gas inspired and expired during each respiratory cycle at rest. So this is here that you are changing the gas volume inside the lung by 500 milliliter, and that is called tidal volume. We have something called also inspiratory reserve volume, which is this quantity here, IRV, and you can see it's from the top of our tidal volume up to a max how much volume we can inhale or inspire. So it's about 3600 milliliters, and it is the maximum amount of gas that can be inspired from the end of inspirational position. Let's take a regular inspiration, and then from that point, before we exhale do expiration at the top of the respiratory cycle, we also inhale more as much as we can in the lungs, and to the max value that is actually our inspirational reserve volume, IRV, and that's where it is. From here, this point to that point is about 3600 milliliters. The second volume or quantity we'd like to talk about is expiratory reserve volume. It's this value here. And the expiratory reserve volume is the maximum amount of gas that can be expired from the end of expiratory level. So here is the expiratory level. So if we are at rest and we are inhaling and exhaling, at the end of the normal exhalation, you also exhale as much volume of air or gas you can until reach the point that is your expiratory reserve volume, and it is about from this point to that point is the volume of it, the amount of gas that we can exhale, force exhale actually, the maximum that we can exhale is about 1200 milliliters. Then we have something called residual volume, and that is how much the amount of gas remaining in the lung at the end of the maximum expiration. So if you're breathing normally at the bottom or the end of your expiratory level, also push all the air out of your lungs till you can't exhale any more of that gas. That is actually what is in the lung. That's the residual volume. And this amount cannot be squeezed out of the lung. Even a collapsed lung contains about 500 to 600 milliliter. So it's usually 1200 milliliter. That's what is the residual volume, RV. So those are all the volumes in the lungs, and they're very important for us to measure. We are going to design instruments that can detect these values, and that is part of biomedical engineering, and that's why we're learning about these quantities. So we were hoping to find ways to measure the tidal volume, inspiratory reserve volume, expiratory reserve volume, and the residual volume. Now about capacities. We have also four important capacities that I would like to explain. So the first one, we have something called total lung capacity, which is TLC, and this is about 6,000 milliliters, and it's the amount of gas contained in the lung at the end of the maximum inspiration. So if you are breathing normally, at the top of your normal inspiration, take as much air as you can, and that's from 0 to that point is actually our total lung capacity. The vital capacity, VC, is also another important quantity, which is about 4,800 milliliters, and it's the maximum amount of gas that can be expelled from the lung by forceful effort from maximum inspiration. So that's the VC. That's how much I can push air out. And another capacity important for us is something called inspirational capacity. And inspirational capacities is IC here, and it is about 3,600 milliliter. It's the maximum amount of gas that can be inspired from the resting expiratory level. So this is your resting expiratory level, and this is how much maximum amount of gas that can be inspired when reaching that point. The functional residual capacity, which is the last quantity that I would like to cover, is actually the amount of gas remaining in the lung. FRC, which is this one here, right? FRC, and is the amount of gas remaining in the lung at the resting expiratory level. It is the sum of the two other values, which is ARV and also RV. And this end expiratory position is used as base because it varies less than the end inspiratory level. So end expiratory position actually is very important for us. At this point here, that's the end of the expiratory level, normal expiratory level, and that's very, very steady, consistent during breathing actually. So hopefully this video presented the most important volumes and capacities that we need to know about and learn about and to know before we go into the more details about designing and testing instruments for respiration, and that is part of our medical instrumentation class. If you have any questions, please don't hesitate to ask and write them in the comment section. I will be more than happy to answer these questions for you. Thank you for watching. Until the next video. Bye.